All right, hey folks, welcome. Thanks for coming to Ignite. My name is Matt Vegas. I'm a principal product manager for the ND series. This is our AI infrastructure virtual machine. I'm here today with Saksham from Black Forest Labs and Param, who's on the software side of our AI infrastructure. And today we're going to talk about our Azure AI infra updates that power frontier and enterprise workloads. So why are we here? Why has Microsoft for the last several years led the way in AI infrastructure? Why have we been building these supercomputers long before other CSPs were interested, even long before ChatGPT existed? These kinds of systems are really expensive and complicated, and they're tough to deal with. And there's really two reasons. It starts with Microsoft ultimately is a user of supercomputers. Whether it's GPU compute or CPU compute, it's been a pretty integral part of our design process, whether it's hardware, silicon, software. The second one is we're in it now, but this AI boom, you could have seen it coming. It was not a question of when, but it was not a question of if, but like when was it actually going to happen? And Microsoft has just this vast portfolio of software products that add value to all of our daily lives, and I see it as the perfect vehicle for delivering AI and delivering value through AI. So this need for AI and really high-end infrastructure has always been intrinsic to what motivates us. It's what drove us to build this competency, and really we get this wonderful privilege to kind of pass on the hard-earned knowledge, expertise, and really our infrastructure to our customers. And so, Microsoft, we're a provider of AI, but we're, at the heart of it is we're really a user of all of this really advanced infrastructure. So, and the need for this compute doesn't end with Microsoft. Obviously, the need for compute is basically exponential across our customer base. Over the last several years, model size in terms of parameters has grown massively. Each new model growing exponentially over the prior generation. We've seen, pure text models evolve into multi-model. Now we're seeing the rise of agentic workflows, long chain of thought. These, really complicated AI processes that are capable of doing, full workflows and deep research on behalf of the user. And so it's really advanced, as we've kind of followed this trajectory. And maintaining this path of innovation for our customer is really what drives us to just build larger, higher performance systems on the latest GPUs. And so kind of needless to say, we've been very, very busy over the last few years just building out a huge footprint of supercomputing infrastructure all around the world. So I'm sure you guys read the news. It seems like every day there's a new massive GPU supercomputer being announced by one of the many competitors out there that are building these types of things. And I feel pretty strongly that Microsoft has always been several steps ahead. If you read the news recently, we announced Fairwater, which is the world's most powerful data center for AI training. Fairwater is multiple whole regions of AI compute. If you typically think of a region as something that hosts all types of services, but these are whole regions basically just designed to do this. We're talking hundreds of thousands of GPUs connected in a massive network, and all of this is real. It's on the ground. It's basically in production, and it's not some future plan on paper and an announcement. This is real. Over the last few years, we've grown our worldwide fleet to support the daily needs of inferencing that we all now use, and it's pivotal in our work, whether it's Copilot or things like ChatGPT. An example of this is from mid-23 to 24, we grew our fleet by 30x. So less than a year, just the amount of supercomputers that we host around the world has grown tremendously. And all of this, basically comes back to just our key principles of building everything with HPC, high performance computing is top of mind. We build custom platforms like fine-tuned for performance. We deliver all of our products basically first to market, so right when they're announced and released. And we take these really advanced designs that are used in the highest end supercomputers, and we give everyone access to them. Like all of these things are built the same, with the same like bar for quality and bar for performance. Our investments on the product side span the entire stack, and this is what enables our customers to succeed. This year we introduced GB200, GB300, RTX 6000 Pro-based VMs. We continue to sell out our massive fleet of A100s and H100s and AMD-based MI300X-based systems. But it takes more than just advanced GPUs to deliver a good cloud service. We've invested heavily in CPU compute for pre-processing, also 800 gigabit XDR backend networking that was released with GB300. We have managed Lustre and object storage services, Cycle Cloud and Kubernetes optimizations. All of this is basically to ensure that we have what we need to efficiently for our customers to efficiently support and run their AI applications. We also continue to invest in the future of AI. We're really excited this week at Ignite. We've launched the GA of ND GB300 virtual machines. These are for AI training and inferencing. It's now generally available, which is a huge milestone for us. We're also excited to announce Azure NC RTX Pro 6000 BSE is now available for public preview. This is a cool platform. It's a single platform for both AI and visual compute, basically so that those two things can work together to accelerate enterprise workloads. In addition, this week we're excited to announce our continued partnership with NVIDIA, and we're basically dedicated to building the future of AI on Vera Rubin, and we're also dedicated to continuing our partnership with AMD to offer more performance and flexibility in the cloud with their upcoming MI455X GPU. So whether it's investments in our GPU systems or our infrastructure stack or offerings of full stack AI solutions, AI innovators choose to run on Azure. This includes OpenAI, Copilot. Just today, Anthropic was announced to be a customer of ours. Copilot runs on it, Figure 8, ByteDance, Meter, OpenAI, and Black Forest Labs, who are, we're really excited to have just these phenomenal customers. So a little backstory before we kind of go to our next segment in this slide, but 2025 has marked a pivotal shift in AI infrastructure. It's really where we went from x86-based servers to Grace Blackwell, which is a completely new architecture that with advancements basically across the design. But it has ARM processors, it has new NVLink that connects the entire rack, and basically enabling the whole rack to act as a massive supercomputer. And so today with us we have Black Forest Labs, who are renowned for their groundbreaking text-to-image generation models, and we're one of the first people to get access to a really large GB200 cluster. And so today I'm excited to have them here. So.
Thank you. Hi, everyone. A bit of introduction about myself. I'm Saksham Kansal, and I lead infrastructure efforts at Black Forest Labs. I joined about a year ago from a startup in the LLM training and serving space, which later got acquired by AMD. So I'm responsible for the training and inference infrastructure, so to train and also serve our models at scale. So a brief description of what Black Forest Labs is. So Black Forest Labs is a leading AI research lab for visual intelligence. We're not just building models, in my opinion. We're actually building foundational technologies that shift how we see and understand the world. So our latest offerings already are integrated into various domains and are built into production workflows, not just in the creative domain, but also in design software and also social media experiences. And I truly believe that we are turning imagination into reality with three things that actually matter in production: speed, precision, as well as creative control. So we launched in August of 2024. We were backed by Andreessen Horowitz and General Catalyst. And right now, we have about 50 full-time employees based in 2 headquarters, one in Freiburg, Germany, as well as San Francisco. So before BFL, our founding team pioneered technologies that defined generative AI, things like VQ-GANs, latent diffusion, stable diffusion. These models fundamentally changed the AI landscape. They made text-to-image generation accessible to millions and set a new standard for what's possible. So in the last 4 years, our work has been cited over 150,000 times. So yeah, in terms of the founding team, there's Robin Rombach. He's our CEO, and he leads the company's strategic directions as well, and building the company itself. That's Andreas Blattman. He leads our go-to-market. He's involved for all our growth initiatives, operations, as well as partnerships. And finally, we have Patrick Esser, the man, the myth, the legend. He leads our research at Black Forest Labs, and he's responsible for most of the cutting-edge research that we do. So in terms of, I'll be remiss to talk about Black Forest Labs without talking about our flagship family. So the Flux series of models are one of the most advanced sets of image generation models out there. Since launch, each and every one of our models have topped the benchmarks for both text-to-image and image editing benchmarks. Our models are available both open weight, so you could deploy this on-premise, and we also have our high-performance models available on our API, and also on Azure Foundry. So in our opinion, this gives customers flexibility that you can deploy them to match your security, cost, and integration needs that are there. So in terms of the models that we have the Flux 1.1, which is like one of the high-quality text-to-image generation models out there. And this is the workhorse that powers a lot of production workflows out there today. There's the Ultra model, which is ultra-fast and for ultra-high-res content. So if you want to get 2K images generated in seconds and not minutes, that's the model you should go for. And then we have the Flux 1 context model, which is the state-of-the-art model both for in-context editing as well as generation. So this combines text and images to generate outputs which are coherent and precise. And finally, a small teaser that we're releasing, we have a new series of models coming out, which is the Flux 2, which is setting the new standard for image editing and generation. And this model will be something that you can deploy to productions and not just for demos. So at BFL, we just don't talk about what we do, but we actually ship it. So every image you see out there on a slide right now have been generated by Flux. And feel free to scan the QR code and try out, or you can go to bfl.ai/play, generate the images yourself, test the control, and see why thousands of people use Flux. Thank you.
Thank you, Saksham. All right, so we're going to switch things up here. We have a little bit of a Q&A that we're going to do. So we can learn more about how BFL uses our GB200 clusters. So, Saksham, working with large clusters of GPUs is obviously not the same as a general purpose compute infrastructure. Walk us through your experience of onboarding an Azure AI cluster and how you scaled to train Flux models.
Sure, yeah. You're absolutely right that we're working with large-scale GPUs is completely different from standard operations and infrastructure. And it's not just on the, especially when training, it stresses the entire systems to its limit. So it's not just the compute plane that we normally talk about, but also the networking, the memory, and also the compute, obviously. So with these challenges, it's been really nice that Azure has been a cloud partner since day one. So from the first customer, we've been one of the first customers on the GB200 NVL72s, and Azure has supported us throughout. So in terms of training, one of the big steps is data. And when you're pre-training, there's so many processes that are touching the scale, and there's so many processes that are accessing the data, and there's so much. The scale of data is such high that the data infrastructure problem becomes pretty intense. And if not handled properly, you're going to have these weird issues like cache thrashing, what else? Partition thresholds being met. So in TLDR, the performance gets really impacted. So we had to work really closely with Azure, the Azure support, the Azure storage team, for example, to really improve the performance and make these workflows work.
That's awesome. So what are some other what are some other considerations you made throughout your experience on Azure? You know, beyond just the GPU, how did you get the infrastructure and services right? You know, how has Azure Infra basically helped you achieve your goals?
Right. So yeah, in terms of like things apart from the compute, I think that three things that I could talk about. One is, for example, like, you know, we talk about GB200s, they're brand new, flashy, new infrastructure available. But it's not just the hardware. There's a lot of software that's also involved. And the Azure team and NVIDIA, we worked closely together to get new drivers, validate on the optimizations that we can do on this new system to actually get the best performance. So that's one. Secondly, I would say networking and storage.
Yeah.
So like pre-training, like it's intensive throughout the entire system. So you know you hit into these weird issues like IB flapping. You're reaching your storage thresholds. Your switch are failing. So you know, working with the HPC and storage team, that's really important to get you know, to identify these common hotpots.
Yeah.
One solution was like finding these like preemptive load balancing, for example, so that we can actually push through the network without having to basically DDoS ourselves. And lastly would be monitoring.
Yeah.
So when you're running pre-training jobs, these jobs are not just like running in seconds or minutes. They run for days, in fact, for months on end. So it becomes anything can go wrong in this period. So identifying when it goes wrong, what went wrong, and actually fixing that as fast as possible becomes essential for actually meeting our target velocity. So that's been something that, you know, really helps with that has helped us out so far.
Oh, that's very interesting. And then how important is orchestration in managing a large cluster like this? Can you talk a little bit about, you know, how you landed on the stack that you're using right now, the benefits of Azure, your experience running Slurm on Azure with Cycle Cloud as kind of an orchestration engine?
Right. I mean, yeah, without orchestration, there is no point of a research cluster. And the orchestrator doesn't just do, like, you know, you're not just putting jobs and does the job allocation, but also does a lot of optimizations on getting the right resources to run your jobs. So, well, to answer the question why we use Slurm, like Slurm is battle tested for HPC workloads. And with Cycle Cloud's help, we had an Azure native solution, which is really closely tied with Azure's infrastructure, which helped us get to use for example, the GB200's rack topology system really quickly. So traditionally, for example, Slurm does not really understand what a rack is. Yeah. But for the GB200s, it becomes really important that you understand what a rack is. Like that's really tight integration on where the node is in the rack and using that rack accordingly. So Cycle Cloud worked really closely with SchedMD to design this rack topology or block topology in Cycle Cloud in Slurm itself, which allows that we can allocate jobs without having to change any on the application layer. So the jobs you're doing rack level job selection, not node level job selection, which then really, I mean, it really improves performance.
Yeah. Now, the pace of innovation in the GPU space has been crazy. I swear, like, it was yesterday we were still installing A100s, and now we've gone through H100, H200, GB200, GB300, and now we're talking about Vera Rubin. I mean, it's just going so fast. You know, what was the experience like collaborating with Azure to get kind of, you know, first or early access to these GB200s? Also, in what ways did it help you having, you know, access to just the absolute cutting edge, highest performing infrastructure?
Right. I mean, it still blows my mind that when you talk about the GB200 stack, we are getting, 13 terabytes of VRAM and 576 terabytes per second of high bandwidth memory. And we get double the T-flops compared to the H100. So you're right, the scale in which compute is moving is really, really, really fast. And this really helps with training. So training for both transformer models as well as autoregressive transform models or diffusion models, both of them are compute bound, which means that as compute accelerates, training accelerates. And things like higher memory, for example, helps in like multiple fronts. You're able to put more weights in a smaller amount of GPUs, so they become more efficient, less likely to break, much easier to work with. You're also able to have higher batch sizes, which people normally think about, but that helps with training performance quite a bit. So those are a lot of things that really improves with having better infrastructure helps with training. So the advantage is that working with Azure and you guys has helped that we being such a small team, we're able to leverage a lot of the support that you guys have given us to actually use the cutting edge to win.
That's wonderful to hear. And then for the audience out there who's maybe just getting started with Azure infrastructure, what are your say top 3 lessons learned?
Right.
Don't hold back the gory details if you need to.
All right. So yeah, I mean, this is I think relevant in my opinion for all infrastructure, not just Azure. But one thing that for me was a really good lesson was learning how to co-design with your cloud provider. So it's not just finding issues which you will have and submitting complaining about it, but actually sitting down with the team and discussing on what's my memory access pattern, what's my data access pattern, and finding out these solutions that we can do. So we were obsessed with collecting metrics and logs and sending them to sending them over, not just to understand the system better, but also to accelerate the improvement. And to Azure's credit, you guys were really quick in getting those fixes in. So I believe working together in tandem really helped us there. Secondly, I think what's really important is focus on the entire system and not just on the GPUs. We always think that you think of training, yes, GPUs, and that's about it. But it's an entire system that's going to be stressed out. Networking, storage, memory, all of those things. So thinking of it in a holistic manner and finding out where your actual bottlenecks are. It's typically not. Sometimes the GPU, not always. So using Amdahl's principle, finding it out is really useful. And secondly, when you're working with really high performance, when you're using something new, like bleeding edge, you put in some time or allocate some time for actually that there might be some engineering effort required.
Yeah.
So you have to put in some work to get the work out. To be honest, so if you're getting 2x compute improvement, think some for engineering development and time. But yeah, those are 3 things I would think about. Yeah.
That's wonderful. Thank you so much for joining us. It's been an honor having you here on stage with us. You're a phenomenal customer.
Thank you. Thank you.
All right, so we're going to kind of switch things up a little bit now. Param Shah is going to present on a different side of our stack, which is the software side of our infrastructure.
Yeah, awesome. Thank you, Matt. Thanks, Saksham. So now that we've seen the hardware side of Azure's AI infrastructure, let's shift gears to the software side and orchestration, because that's where the GPU power really comes to life, right? Because at the end of the day, you can have all the latest and greatest GPUs, but it's also about how you can deploy, manage, and scale them for your workloads. So across Azure's AI software stack, we've designed our offerings around how you build AI. And at a high level, there's 2 main paths, right? If you want to start with pre-trained models, you should go to Azure AI Foundry, right? Here you can focus on fine-tuning and agent creation. If you want to train your own custom models, you can use AKS if you're already on Kubernetes, or CycleCloud if you want to bring in your own scheduler and get your training infrastructure up quickly. So on the left, as you can see, you get a managed experience, right, where you can use built-in models and tools for fine-tuning. And on the middle, you can see the Kubernetes, our AKS service, where if you have containerized pipelines with DevOps integrations, then that's your natural fit. At the end of this presentation, I've also linked some fun AKS and AI Foundry sessions that you guys should feel free to go look at. And at the very right, oh, went too far. Let me go 1 slide back. Cool. Yeah, so on the right side, if you look, we have CycleCloud, where if you're bringing in your own scheduler or workflow manager, like Slurm or PBS Pro, and you want that fine-grained control over your distributed AI or HPC workloads, then CycleCloud is built for that. So today we're going to focus on that right side, right, the customizable side of the spectrum, where teams can orchestrate compute at massive scale with end-to-end observability and deep insights. So before we get into that, I'm just going to give a high-level overview of what AKS is, Azure Kubernetes Service. So that is our fully managed Kubernetes platform for AI. So it provides GPU-optimized infrastructure. It gives you dev-friendly tooling. You get intelligent scheduling, built-in observability, and finally, secure networking. So you get all of that in one Kubernetes native stack. And moving on to CycleCloud. So what exactly is that? CycleCloud is Azure's enterprise-friendly tool for orchestrating and managing HPC and AI workloads in the cloud. So it allows you to easily deploy, manage, and scale your HPC or AI clusters with the scheduler of your choice, whether it's Slurm, PBS Pro, LSF, HD Condor, you name it. And you can also provision infrastructure, attach storage, deploy your scheduler, like I said, and scale based on the demand you have. So the beauty of this really is that it meets you where you are, right? You don't need to rework your existing tool chains or workflows. So in other words, CycleCloud gives you that flexibility without any of the friction. And we also like to take it one step further. So we have Azure CycleCloud Workspace for Slurm, or CCWS for short, which builds on top of CycleCloud. And it provides a single pane for deployment, management, and observability. So the big takeaway here is that it gives you instant cluster provisioning so that you can deploy a Slurm cluster in minutes instead of weeks. It's also built on enterprise-ready architecture. So it takes care of your secure virtual networking. It gives you flexible storage options like NFS, NetApp files, Lustre, and it also gives you that unified operations and insights. So you get end-to-end health monitoring, Grafana dashboards for cluster analytics, all while being integrated with Linux VDI and Open On Demand for seamless management. So in short, it takes away the complex cluster management that you would have and makes it into a simple managed experience from deployment to monitoring so that you can get your cluster up and running just like BFL did. And so now we have a quick demo. I'll play it. I'll play maybe like a quarter of it and just talk through. So basically what we show in this video is the HPC and AI convergence story, right? So there's no audio on, but it's in CycleCloud Workspace. What we do is, like you can see, open up an Open On Demand session, get into VS Code, and what we do here is in that VS Code session, we're setting up an AI agent. And what that AI agent does is it's able to build the Slurm script for OpenFOAM, but then also be able to debug that. And so throughout this demo, what we're doing is we're defining the agent profile, right? We're giving it a prompt on what it should exactly do, what are the parameters. Then we run into an error. So with that error, we tell it to debug that. We give it the error file, tell it to fix it, and then finally, after it fixes it, we let it submit the job. So the analogy I like to think of in this HPC AI convergence story is to think of the agent like a car. So it's very powerful, but you still need a driver's license at the end of the day, right? You need good prompts, you need good tools, and you gotta give it the proper context. Now, another neat capability we have is interconnect groups, or ICG. You might have heard Saksham talk about these, and what it does is it brings rack-aware allocation to Azure's newest GPU systems. So with the hardware like GB200s and GB300s, the real unit of compute is an entire rack. It's not just a single VM. And now ICG ensures that your workloads land on the right rack to unlock that full NVLink and InfiniBand performance. And if you have rack reservation, you can get visibility into your rack, into the racks that your VMs are placed on, and you get health-aware empty node queries. And finally, today, we are excited to announce the GA of CycleCloud 8.8 and CCWS 1.2. So in CycleCloud 8.8, some of the big things we've added is Ubuntu 24.04 and Enterprise Linux 9 support. So we've basically expanded our OX flexibility across Red Hat, Alma Linux, and Rocky. And now next is one of the most important additions, which is the Node Health Agent. Now this is important because in large AI and HPC clusters, jobs can run for days. And once they're running, you absolutely don't want to interrupt them. And so the Node Health Agent subscribes to these health events and allows you to monitor them in real time. It also brings in two different classes of checks designed specifically for these large, long-running GPU workloads. One is these non-invasive checks, which run while your jobs are running. They're very lightweight. What they do is they monitor things like the GPU presence, and if a problem is detected, they'll automatically drain it without killing the active job. The other one we have is invasive checks, right? And so these invasive checks are deeper stress-style tests that only run when the node is idle. They never run during a user's job. What they do is that they validate the GPUs and interconnects, make sure that they're fully healthy before the next job lands. And so together, these two give a customer much more of a safer environment altogether, especially for those long-running AI jobs, because it catches these hardware failures early and then also protects the jobs that are already in flight. We also have ARM64 and HPV Vive support. So for ARM64, that includes the GB200 and GB300 architectures, and we also have support for the HPV Vive series for your next generation of AI and HPC systems. And then finally, for the CycleCloud side, we have topology-aware scheduling. So the CycleCloud integration with Slurm ensures that these distributed AI workloads align with the GPU cluster. And that includes the cluster backend topology so that you can get the best training performance that you want. Moving on to the right side, so CCWS 1.2. One of the biggest features we have is the managed monitoring integration, which visualizes everything in an Azure Managed Grafana instance for a unified GPU and InfiniBand telemetry. So it does this by installing the NVIDIA DCGM exporter and Slurm exporter, which pushes end-to-end metrics into a self-hosted Prometheus database. And what this does is it visualizes it in an Azure Managed Grafana. So you get that job to GPU level drill down that you want. We also have availability zone support. So what this does is it allows co-location of your GPU compute and storage within the same availability zone so that you can minimize your storage access latency. Next, we have Entra ID authentication. So that's supported right now with CycleCloud UI and Open On Demand. And finally, we have the Open On Demand integration itself. So for those of you who may not know, Open On Demand gives you a simple browser-based access to access shells, files, interactive apps, VS Code like we saw in the demo. And finally, we have the Linux VDI capability. So we've done this through a partnership with Sendio ThinLink. They've built on top of an open source software. And what that does is it enables interactive GPU-accelerated desktop workflows directly in the cluster environment itself. And that is the end of the session. If you enjoyed it and you want to learn more about AI Foundry and Azure Kubernetes Service, please feel free to check out these sessions on the screen. So thank you all for coming, and thank you, BFL, for being a valued customer.